We're now on to vectors. First one is about displacement. Distinguish between distance and displacement. Right? Distinguish meaning what's the difference? So simply, distance is a scalar quantity, meaning it only has a magnitude. So distance, we say I walk for 5 kilometers, right? I've given a distance and I've given the magnitude, right? The amount of distance that I walked, 5 kilometers. However, displacement is a vector quantity, meaning it has both a magnitude and a direction. For example, I walked 5 kilometers to the east. I've given a magnitude, 5 kilometers, and a direction, east. Part B, you walk 10 meters right and 15 meters up. Draw a vector diagram showing this. Draw the displacement vector and calculate its magnitude and direction. Cool, so that should be, draw the, resultant displacement vector. So, vector diagram, 10 meters to the right, so let's put a dot to start off, 10 meters to the right, so I will draw an arrow to the right, and I will label its magnitude with 10 meters, and then 15 meters up. Now, is that a sensible diagram? No. Right, the magnitude corresponds to the length of the arrow, and so 15 meters is greater than 10, so my upwards arrow should be a bit longer than my arrow to the right. And there is our vector diagram showing that scenario. Part 2, draw the resultant displacement vector, calculate its magnitude and direction. So the resultant displacement vector is the vector connecting the tail of the first leg to the head of the second leg. Right? When we add vectors, we add them by connecting the tail of the first to the head of the last. Right? And with two legs, two vectors, it's a lot easier to see this. When you have multiple vectors, it can be a little bit harder, but just remember that rule. Tail of the first vector to the head of the last vector. So we've drawn our vector, but we need to calculate its magnitude and direction. So let's start with the magnitude first. Looking at this, since we went right and then up, this is actually a right angled triangle, and we can calculate the magnitude using Pythagoras' theorem. So let's label this D, and it will be like these bars on the side just mean the magnitude, so the magnitude of D. So let's look for that. So the magnitude of D is each side squared and then all square rooted. Right? You'd remember from last year, Pythagoras' theorem, like c squared equals a squared plus b squared. In this case, a and b are the legs, 10 and 15, and then c is the hypotenuse or the resultant vector. Okay, so we can compute that. Getting out our calculator, 10 squared plus 15 squared 325. And then looking at that, that's a large distance, so we've obviously missed the last step, which is to square root. So shift square root, shift answer, which is to 2 sig fig 18 meters. Now this distance is actually only to one significant figure, so we should, if we're being proper about this, we would round our final answer to 1 sig fig to be in line with the precision that we're given in the question. Okay, so we found the magnitude, but we know that displacement is a vector. It has a magnitude and a direction. So how do we find the direction? So the question specified to find the angle anti-clockwise from the horizontal. So back to our diagram. Horizontal being left and right the flat, anti-clockwise from that. So it's asking for this angle here, which I'll label as theta. So to specify a direction, you do need like a reference frame. So in our case, we're taking it anti-clockwise from the horizontal, as given by the question, but sometimes you need to make up your own decision. Again, think back to last year, trigonometry. How do we find this angle? Right angle triangle, we can use SOHCAHTOA. We were given opposite and adjacent. We did calculate the hypotenuse, which you could use, but I recommend using what you're given to avoid a rounding error. So here we'd have tan of the angle is equal to the opposite divided by the adjacent, so 15/10. And to compute the angle, we need to take the tan inverse of both sides. And so let's do that. Shift tan brackets 15/10. Now, does that look reasonable? 0.98 degrees. No, right? It should be closer to 45 because these are similar lengths. So what happened? Yeah, you guessed it. We are in radians. So whenever you go into an exam, your calculator is reset. So we need to go Shift Menu, change our angle property to degrees, F1, exit, and we'll try that again. Tan inverse, bracket 15 divided by 10, close bracket. There we go. 56.3 degrees. Or to one significant figure, that would be 60 degrees. So we've calculated the magnitude, we've calculated the angle, so we can put it together with our final answer. So we would say displacement is 20 meters, 60 degrees, counterclockwise from horizontal. And it is clearly shown in the diagram, right? Because I've labeled theta going counterclockwise, so this bit is technically optional with a good diagram, but I'll put it in there for clarity. Alright, I think I might go for a walk 10 meters to the right and 15 meters up. I don't know how I'm going to do that, but I know it's going to be about 20 meters.